Good morning, dear students, and welcome back. As we have discussed that chemical reactions are accompanied because of chemical changes, chemical reactions are primarily of five types. They are listed as follows: combination reactions, decomposition reactions, displacement reactions, double displacement reactions, and oxidation and reduction reactions, also known as redox reactions. Combination reactions involve two or more substances combining to form a new compound. The reactants in such reactions can be elements as well as compounds. The general equation used to represent a combination reaction is A plus Z Az. For example, coal, which is primarily carbon, when burned, it combines with oxygen present in the air to form carbon dioxide. On heating, magnesium combines with oxygen present in the air to form magnesium oxide. Hydrogen and oxygen combine to form water molecule. Calcium oxide, which is a compound also known as quicklime, when mixed with water, reacts with it to form calcium hydroxide, also known as slaked lime. The chemical equation for the same is given as CaO plus H2O gives Ca within bracket OH whole 2. In combination reaction here, two compounds or more even combine to produce only one product. Generally, combination reactions are exothermic in nature, where heat is or energy is released when two or more substances combine. Combination reactions are also known as addition reactions. Opposite to it is decomposition reactions. In these reactions, a compound breaks down or decomposes to form two or more substances. These reactions are exactly opposite to combination reactions. We know that there is only one product in the combination reactions. Similarly, there is only one reactant in the decomposition reactions. The general equation used to represent a decomposition reaction is AB, a compound which has a big molecule breaks down to A plus B. Decomposition reactions required a source of energy in the form of heat, light, or electricity to decompose the compound involved. Hence, these reactions can be classified into three types depending on the source of energy for the reaction. Decomposition by heat is known as thermal decomposition, thermolysis. Decomposition by electricity is known as electrolysis. Decomposition by light is known as photolysis. Thermolysis or thermal decomposition. One of the most common examples of thermal decomposition reactions is decomposition of calcium carbonate. When heated, decomposes to form calcium oxide and carbon dioxide. When electricity is passed through water containing a few drops of sulfuric acid, it breaks down to give its constituent elements as products, hydrogen and oxygen. This is known as electrolysis of water. When silver chloride is kept in the sun, it decomposes to form chlorine gas and silver. As the reaction proceeds, the white colored silver chloride turns gray because of the formation of silver. Chlorine produced in the reaction escapes into the environment as it is produced in the gaseous state. This is photolysis. Third, displacement reactions, which involves a more reactive metal displacing a less reactive metal from later salt solution. Displacement reactions are of two types: single displacement reactions or double displacement reactions. Single displacement reaction can be observed with the change in color of solution where one highly reactive metal displaces less reactive metal from the salt solution. This can be understood with the diagrammatic representation of the given figure. In the above figure, we have three blocks. It will be observed that while red and blue blocks are fixed in, green blocks is aloof. Now the blue box or block is attached from the red and fixes into the green. It means that green displaces the red block. In a single displacement reaction, an uncombined single element replaces the another one in a compound. When two sets of displacement occur, it is double displacement reaction. Again, this can have the representation from the block given here. A double displacement reaction is a bimolecular process in which parts of two compounds are exchanged to give two new compounds. Double displacement reactions have two common features. First, two compounds exchange their ions, resulting in the formation of new compounds. Secondly, one of the product formed would be separated from the mixture of reactant in some way. It can be either as in the form of precipitate, gas formation, or as an acid-base neutralization reaction. Depending on the product obtained, double displacement reactions can be precipitation reaction or neutralization reactions. Last, oxidation and reduction reaction involves two processes which occur simultaneously. Oxidation, which is defined as a process which involves gain of oxygen, loss of hydrogen. When a substance gains oxygen or loses hydrogen during a reaction, it is oxidized. Reduction. It is defined as a process which involves a gain of hydrogen or a loss of oxygen. So when a substance loses oxygen or gains hydrogen during a reaction, it is reduced. Oxidation reduction always take place simultaneously. Therefore, reactions involving oxidation reduction are known as redox. In a reaction, one substance is oxidized, other is reduced. The substances that are reduced provide oxygen or remove hydrogen in course of reaction are oxidizing agents. These substances oxidize other chemicals in the reaction and are reduced in the process. On the other hand, the substances that are oxidized, remove oxygen or provide hydrogen are called reducing agents. For example, carbon dioxide reacts with hydrogen to form carbon monoxide along with water. We can see carbon dioxide removes its one oxygen atom to form carbon monoxide. Removal of oxygen, that means, is being reduced. Hydrogen combines with one oxygen atom to form water molecule. Addition of oxygen resulted in oxidation. Hence, carbon dioxide is providing oxygen, is the oxidizing agent of the change. Hydrogen is using the oxygen, is therefore reducing agent of the change. Corrosion. It may be defined as a process where materials, usually metals, are deteriorated because of a chemical reaction with air, moisture, chemicals, etc. Corrosion causes damage to bodies, bridges, railings, and ships and other objects made up of metals, especially of iron. Iron in presence of moisture reacts with oxygen to form iron 3 oxide hydrated, and this reaction is presented as given here. This hydrated iron 3 oxide is rust. If not controlled, rusting can corrode the entire iron present in an object. As rust is softer than iron, the strength of the object decreases while rusting takes place. Rancidity. When fats and oils are oxidized, they become rancid and their smell and taste also changes. Thus, oxidation of fats and oils can easily be observed by change in their taste and smell. Since oxidation reduction reaction help to get many substances and are used in the synthesis of chemicals, compounds, products, corrosion and rancidity are considered as two main disadvantages of redox reactions or oxidation reduction reactions. This needed to be prevented. Oxidation of food can be prevented in many ways. This rancidity can be commonly reduced by two ways. First, storing food in airtight containers. By doing so, the oxygen available for oxidation becomes limited and hence oxidation can be prevented. Sometimes antioxidants are added to food to prevent their oxidation. These antioxidants are oxidized first, which slows down the process of rancidity. These are reducing agents. Normally, vitamin C and E are added as antioxidants. So, in this lesson, we have completed all the substances. The next, we will see lesson 2 as part of our revision.